Okay, to continue with this part 2 of our exception situation, there are some basic things that we need to understand about all the throwable classes. One, there are some basic methods like a message. So for example, let's go back to the very basics and do something as simple as int x equals 2, int y equals 0. Let's assume that we caught an exception, and then e.print stack trace. We're just going to print the entire stack trace. Let's do x divided by y. That, because it's a division by 0, in this case the compiler, I think the compiler is getting smarter than I am. Let's do x equals x divided by y. Something as simple as that. And what this is going to do is that it's going to give us an arithmetic exception. And this print stack trace is going to print this part. And if we have, multiple layers of functions, let's do public void my function, and then from here we do another function, my function 2. So actually let's make it all static so that way I don't have to create an object. So I'm just making everything, I don't have to create an instance. Let's bury this exception deep into function 2, and then we do my function 2, and then from here we do my function. So basically in this program we're going to call this function, who calls this function, who calls this function, and this is what causes the stack trace. So if we run this, we can see that it's telling us how the progression happened. So line 23, which is how it started, then it went into line 9, and then into line 16 when the problem happened. It tells us how deep we went to the code. Okay, so now that we explained what is the stack trace, there are other components like, we print the stack trace, we can convert the exception to string and then print that. And now we have a Java-lang arithmetic exception, division by 0. That just gives us a basic. It doesn't have the stack trace. It just tells us the information of the string. If we do get message, we will see that the exception printout, it just says divided by 0. It's not telling us the name of the exception. It's just telling us that there's a division by 0. So we can grab different parts of the exception class, and even a localized message. You say, like if we're in French, we could get a localized message. Let's see if get localized message. Let's see if in our code, well, it's because we're in English. Anyway, so it gives us just different representations, just given what we want to do with the exception. We cannot even print it, but it's really useful sometimes to have like what are the problems that happened and what was in the log or things like that. So then to really drive down all these exception stuff, I want to talk about custom exceptions. We already talked about chain exceptions and throwing exceptions, but what I want to talk about is the last element of the block, of the try-catch block. So in a try-catch block, there's a finally statement, and that finally statement happens regardless if the exception was caught and fixed or if the exception was never really emitted. In other words, let's show what this thing does. So the finally is really useful for a cleanup method. Whenever we opened a file or something and something happened in the process, we can clear a file, close a socket, close the things that were open, do a cleanup, things like that. Just making sure that we wrap things up regardless of the execution of the method. So if I run this code and we print the message division by 0 and then finally happened here. Now, if I comment the exception thing, just the line that is throwing the exception, we're going to see that finally still was called, because after this block executed, regardless of it being successful or unsuccessful, this is going to execute, which is really important. Another thing to know is that we can create our custom exceptions. And the easiest way to create a custom exception is by creating a class that is just inheriting from one of the throwables. So for example, we can call this, and IntelliJ is really smart at just detecting the name and filling in the gaps. So let's call it JC's custom exception. When we do this, we can do like extends exception. And with that, we can create a custom exception. So we can, let's just delete this and we can do throws new JC custom exception. Throw new, not throws. Throw new. Throw JC custom. Let's just put it as generic exception because this is a parent, so these two are the same. And because this one, let's wrap the code here. Well, you can see that because I'm kicking again the bucket, this guy is now wanting to catch it. So I can even keep throwing it all the way upstream, and now this guy is the one that has to be that responsible for it. So now when I throw it, I get JC custom exception. Now, if we hadn't defined that class, and let's delete that file. If I had created JC custom exception by just typing, let's call it JC custom exception 2. And if I alt enter, it can say create class JC custom exception. And we just select the package, we leave it empty. And you can see that it extended from throwable because it detected that it came from a throws method. Why is this guy saying that it's unhandled when it's saying throws exception? Because if you guys remember in our slides, we were trying to catch this one. So we need to say that this guy is going to throw a throwable or change the root to an exception. And now it's going to catch everything. So that's how you can create custom exceptions. So why are custom exceptions useful? Well, let's go back into an example, and what we're going to create is we're going to call this class called ATM. This class is going to wrap all the concepts that we have taught about exceptions in one single class. When you go to the ATM, you have a pin, and let's say that our pin is 1, 2, 3, 4, and we have a balance. Let's say float balance, and we have $1,000 on it. In our balance, we're going to create a function called public void withdraw. Actually, let's just leave withdraw, and we're gonna withdraw a float amount, and from that withdraw amount, actually, let's make it as a float because it's going to return the money. If you're successful getting the money, you're going to get the money back. So we're going to return amount. But two things can happen in this situation. First of all, when you're trying to withdraw money, you can have the PIN incorrectly. So we need to pass the PIN and the amount. So if this dot PIN equals PIN, or let's say if it's different, then we throw an exception. We throws, let's say, ATM incorrect PIN exception. Throw new, not throws. Throw new. And then also another thing that can happen is that we don't have enough balance. So if balance is less than amount, then throw new ATM insufficient funds exception. Right? We don't want to give money if somebody is not authorized, and we don't want to give money that you don't have. Then at the very end, we can do balance equals minus equals amount, and it's going to return the amount. So two things that we need to do here. Alt enter, we can create the exception. We're gonna put it in the same package. Same thing, Alt enter, create, put it in the same package. And we're gonna say that this code throws an incorrect ATM exception and an insufficient funds exception. Okay, so what we're going to do now is that we're going to create an ATM class. ATM, my ATM equals new ATM. And in this particular case, we're going to do a try catch. And you guys have all been to the bank, and when you withdraw money, you also want to, once you either successfully or unsuccessfully withdrawn money, you would have gotten the beep that you need to take your card. So we're gonna simulate that by using please take your card. That's the finally. It gets called regardless of the issue. So we're going to then first of all say my ATM dot withdraw. Let's say float amount. Let's say that we're gonna withdraw from a pin 1, 2, 3, 4, and we're gonna say we're gonna withdraw $100. Yeah, it converts it automatically. And because this is now complaining about the exceptions, we're gonna use first of all the incorrect pin exception, saying pin, and then we're going to put the other exception here, which is insufficient funds. So in both of these situations, we want to be able to give the user the right amount. And also, before we continue, we're gonna my ATM, let's actually say string message equals string.format, and we're gonna say %F was retired, was withdrawn, and the balance is %F, and we can now say amount and my ATM dot balance. Okay, and then we're gonna print the two different messages saying for the pin, incorrect pin was passed. And for this guy, we're gonna say insufficient funds were available. In a very simple class, we're using the keyword throws to say how we're going to kick the bucket of an unhandled exception, letting the user determine, the writer of the code determine how they're going to handle it. So we're getting an incorrect exception pin, we're telling the user, or the insufficient funds, and we're catching that and telling the user. And in all of those cases, we're going to ask to withdraw the card. So in this case, we do have everything correct, and it should withdraw the money correctly. And it says that 100 was withdrawn, and now our balance is 900. But now what happens if we do 1, 2, 3, 5? Incorrect pin was parsed. Please take your card. And let's do 1, 2, 3, 4, and let's do $2,000 that we're gonna withdraw. You can see that insufficient funds are available. So this basically encapsulates how all the concepts that we've talked about, the exceptions and ATM. For the homework, in this case, we're gonna try to use exceptions to start figuring out if two passwords match. And like those attempts that when you're trying to log in and or one of those where you're trying to fill in an internet form, we're gonna try 3 times with incorrect passwords, and if the third time the incorrect password is entered, then we're gonna say that there's a security warning, basically simulating the fact that your account gets blocked after 3 attempts. So this is the pseudocode. This is what I would like you guys to submit via Canvas. I hope that everything was clear. There's one extra thing I'm going to talk about, just to really include everything here, which is the stack. This is another data structure, very similar to a queue. The thing here is that, or even to a linked list, if you want to think it that way. But the very interesting thing here is more about the behavior of the structure. If you think about of a stack of coins, that stack of coins, they're just piled together, and you technically, or even if it was a stack of dishes, a stack of books or something, it's a lot more difficult to lift everything up just to grab the one in the bottom. So the easiest way to do it is by taking the one at the top and removing it from the queue until we get to the element that we want. That technique is called LIFO, which means last in, first out. A stack has two operations, a push and a pop. A push operation puts things in the stack, and a pop removes the operation from the stack. This is an example where, in this case, if we wanted to work the stack and we wanted to figure out the node, we would basically create a stack exception for whenever we hit the end, or we're trying to like remove something that doesn't exist. This is a good exercise just to warm up and to make sure that everything is handled okay. So I'm gonna post this in Canvas as well, but the homework is a password checker. Okay, so I hope you guys are learning, and if I can answer any questions, just hit me up and I'll try to answer any questions that you guys have. Thank you.